Okay, this is chapter 10.5, angle relationships in circles. The essential question for this chapter is when a chord intersects a tangent line or another chord, what relationships exist among the angles and arcs formed? So what you will learn in this chapter is how to find angle and arc measures and how to use circumscribed angles. So let's take a look. Okay, so let's start this chapter with another theorem of the 14th theorem. 14th theorem in this chapter section. Tangent and intersected chord theorem. If a tangent, I don't want to go off on a tangent here, but if a tangent and a chord, whoops, picked the wrong thickness. How about down here? All right, so there's the tangent and there's the chord. If they intersect at a point on the circle, right here, point A, then the measure of each angle formed is half the measure of its intercepted arc. Okay, so this arc right here, obviously, is less than half of a circle. Let's just say that is, I don't know, 100 degrees. If this was 100 degrees, this AB arc, then angle 1 formed by that chord and that tangent would be half of that, or 50 degrees. This would make this side, since this is a tangent is a straight line, that would make a linear pair. And if this is 50, then angle 2 would have to be 130 degrees. If that is 130, then arc ACB would have to be 260 degrees. And 260 plus 100 is 360, or a full circle. Okay, so let's take a look at that in some examples. Okay, so let's put theorem 10.14 to work right here. All right, so here we have tangent. Line M is a tangent. So I'm going to label this as a tangent. This right here is a tangent. Okay, a line segment or a line that touches a circle at one point. AB, this right here, is a chord. So we have a chord intercepting a tangent on the circle at point B. With that, we can say that the measure of angle 1 equals 1/2 the measure of arc AB. Okay, and that's what the theorem says. A tangent and a chord intersect a circle or intersect on a circle, then the angle formed is half the intercepted arc. So now I substitute my givens. The measure of angle 1 equals 1/2 of AB, which is 130 degrees. So the measure of angle 1 equals half of 13 is 6, with a remainder of 1, half of 10 is 5. So the measure of angle 1 is 65 degrees. So I want to take this one step further. So if this is 65 degrees, once you find one and it's breaking the triangle or breaking the circle into two pieces, you can find everything else. Since this is a straight line, these are linear pair. 180 minus 65 is 115 degrees. Double that and you get 230 degrees over here. 130 plus 230 is a full circle, 360. So given one arc measure or one angle measure, you can find the other angle and the other arc. Okay, so let's take a look at the next problem. So again, I'm going to use a highlighter this time. Okay, here is our tangent. And here is our chord. And here is our point of intersection on the circle. So now I can use my theorem and say the measure of angle, I don't know how to name that because that's point L and that's point K up here. I can't just call it angle L because there's two angles here. I'd have to put another name or letter out here. So this is angle KLN. So I'm going to call that that. The measure of angle KLN should be capital. Just thinking here. Okay, this is N. The measure of angle KLN equals 1/2 arc KJL. Notice it's a major arc, okay, if J is over here. So the measure of angle KLN is 125 degrees, and that equals 1/2 arc KJL. In order to solve this, you multiply both sides by 2 to get rid of that half. So 1/2 times 2 is 1, and I get arc KJL, the measure of arc KJL, there should be an M here, should be an M there, equals 2 times 125, which is 250 degrees. Okay, and again, once you find that, 180 minus 125 is 55. And double that and you get 110 degrees, and 250 plus 110 is 360. You can always check and find everything else. All right, so now that I've shown you example 1, you should be able to do exercises 4 and 6. All right, core concept, intersecting lines and circles. If two non-parallel lines intersect a circle, obviously they're non-parallel because they wouldn't intersect at all. There are 3 places where the line can intersect, okay? And I've mentioned this in class, but it can be on the circle, forming an inscribed angle. It can be inside the circle, forming an interior angle, or they can be outside the circle, forming an exterior angle. Okay, so now let's take a look at these theorems. So that's weird, okay. All right, so here we go. Theorem 10, 15 and 10, 16. Not much to remember in this chapter, is there? 16 theorems. All right, so theorem 15 says angles inside the circle theorem. Okay, here's an interior angle right there. Okay, they intersect, the two non-parallel lines intersect inside the circle. If two chords, BD and AC, intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs. And you're like, what? So here's angle 1 right here. It intercepted arc DC and it intersected arc AB. So the angle measure equals 1/2 the sum of those two arcs. All right. So you add DC to AB and divide by 2. It's an average. So the angle is the average of the arcs intercepted, just like angle 2. Angle 2 is right here. Well, angle 2 intercepts arc BC. And this angle over here, if I called it 3, that would intercept arc AD. So angle 2 is vertical to angle 3. So the two arcs they intercept, AD plus BC, right here, divided by 2, would be the measure of angle 2. All right, that's the inside the circle theorem. Now for outside the circle, we can either have a secant and a tangent, 2 tangents, or 2 secants. Those are the 3 possible outcomes. If a tangent and a secant, 2 tangents, or 2 secants inside intersect outside the circle, here's our intersection point, they're all outside, then the measures of the angle formed is half the difference. Okay, if it's inside, it's sum. If it's outside, it's difference. So I have this angle here. So here it intercepts this big arc, BC, that's the larger arc, and then the smaller arc is AC, BC minus AC divided by 2, PQR minus PR divided by 2, and XY minus WZ divided by 2. Okay, so we're going to take a look at those. There are proofs if you want to read them. And let's take a look. Okay, so let's find an angle measure, find the value of X. So what kind of angle is this? Where do the two chords intersect? Well, it's inside the circle. So this is inside. So we add. All right, add divided by 2. How about that? This one, the angle's here. We have a tangent, we have a secant. That is outside. So when it's outside, we subtract and then divide by 2. So add, divide by 2, subtract, divide by 2. Those are the rules. All right. So notice here, though, this is not a central angle. The center of the circle is somewhere down here. This is not a diameter. This is not a diameter. These are two chords shorter than the diameter. All right. So the measure of angle X is the measure of angle X equals 1/2 130 degrees plus 156 degrees. If you're inside, you add. If you're outside, you subtract. So the measure of angle X equals 1/2, and 6 plus 0 is 6, 5 plus 3 is 8, 1 plus 1 is 2, and we get 286 degrees. The measure of angle X is half of that. So divide this by 2, and we get 143 degrees. So the measure of angle X is 143 degrees. So therefore, this is 143 degrees because they are vertical. This is a straight line. And so what I'm pointing out here is once you find one, you can usually find the rest of the circle. So if this is a straight line, 180 minus 43 is 37 degrees. And this is 37 degrees. Okay. Now, since these are 37 degrees, these two arcs right here add up to double 37 or 74 degrees. This plus this is 74 degrees, but we don't know if it's 73 and 1 degree or 72 and 2 or 71 and so on and so on. So that's as much as we can do in this circle without knowing one of the arcs. We don't know what two values will double 37. All right, just keep that in mind. All right, now the next one, we have circles, the circle here with a tangent and a secant and the angles outside. So we're going to take the two intercepted arcs. So let me highlight those. So we have one intercepted arc, which is right here. That is the larger of the two. That goes from this point here to this point here, okay, where the secant intercepts the circle and where the tangent intersects the circle. And then we have this smaller portion right here. Oops, I don't want that to be straight. Okay, right there. So what we're going to do is we are going to take the measure of angle C equals 1/2 arc. And that's a major arc. And we're not going through B, so we can, I guess we could just call that. Well, let's just fill it in. 178 degrees minus 76 degrees. Okay, so the measure of angle C equals 1/2. 8 minus 6 is 2. 7 minus 7 is 0. 1 minus nothing is 1. So this angle is 1/2 of 102 degrees. So the measure of angle C equals 51 degrees. Okay, and that is our X. So X is, I guess I should say that, X is 51 degrees. And over here, yeah, X is 143 degrees. Okay, so that's how you do an interior angle and an exterior angle using the chords. Now try it in exercises 8 and 10. Okay, more core concepts and more theorems. Can you believe it? There's 17 theorems now in this chapter section. Oh. All right, core concept, circumscribed angle. A circumscribed angle is an angle whose sides are tangent to the circle. Okay, so in other words, two tangents. So BA is a tangent and BC is a tangent, and it's an exterior angle, and it is circumscribed angle because the circle is inside the angle entirely and touching the edges. So theorem 1017 says if you have circumscribed angle theorem, the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. Okay, so what they're saying is, let me highlight this. The measure of a circumscribed angle is equal to 180 minus the measure of the central. So if you have two tangents, then angle D is a circumscribed angle. So the measure of the circumscribed angle is equal to 180 degrees minus the measure of the central angle. So here's the center of the circle, C, and it's forming a central angle ACB. So you take 180 degrees minus that central angle, and that's your exterior angle. So if you don't know the arc measure AB, the major arc, and if I should have another dot out here because I can't name two arcs the same name because this little one would be AB. So if I put an E here, then arc AEB is the major arc and arc AB is the minor. If I don't know those two, I can't say, well, this arc minus this arc divided by 2 is this angle. It is, but if we don't have that info, then we have to use the central angle in this theorem. So let's take a look at that in an example. Okay, so finding angle measures, find the value of x. So I'm going to highlight what we have here. We have a tangent, and we have another tangent that forms a circumscribed angle D. So we say the measure of angle D equals 180 degrees minus the central angle, which is right here, minus the measure of angle ACB. So the measure of angle D is x, and that equals 180 degrees minus 135 degrees when I substitute. So x equals 180 minus 135, which is 45 degrees. Okay, so this diagram here is a little more tricky. They're asking for the interior angle, or the inscribed angle. I'm sorry, it's an inscribed angle. This angle is on the circle, but I don't know the measure of arc EF. Okay, but if we use this theorem, then we can think of it this way. Okay, example B is a little tricky. So let me start by doing this. Okay, we don't have a central angle, so let's draw one. Okay, so it's right there. Let me make these a little thinner. Okay, so we have a central angle here. Okay, so what do we know about this? Well, this is an interior or an inscribed angle. The inscribed angle, so the measure of angle EJF. All right, so let me highlight that. I'm talking about this angle right here. It's an inscribed angle. The theorem says that the measure of EJF equals 1/2 its intercepted arc. So that's going to equal 1/2 the measure of arc EF. Okay, which is right here. But unfortunately, I don't know that. So what do I do next? Well, the measure of angle EJF, where'd my E go? Start over. EJF, the measure of arc EJF is going to be 1/2 of arc EF, which is going to, since this is a central angles equal their intercepted arc. So now I can say that the measure of EJF is going to equal 1/2 the measure of angle EGF. Okay, hopefully you're following this. This is an inscribed angle. It equals 1/2 its intercepted arc. The intercepted arc is equal to the angle, central angle. So therefore, EJF is equal to 1/2 the central angle. So when you have an inscribed angle, it's 1/2 the central angle if we share the same points of tangency where the chords meet. Okay, so that's what we have so far. Well, the measure of angle EJF equals 1/2 of 180 degrees minus the measure of angle EHF. Okay, so let me go back here. So the central angle, the measure of the circumscribed angle is equal to 180 minus the measure of the central. Okay, so think of it this way. The measure of angle EHF equals 1/2, or not 1/2, 180. The measure of the circumscribed angle, angle D, equals 180 minus the measure of the central angle. Okay. EHF is 30. That's going to equal 1/2 of 180 minus ACB. So this angle here, ADB, equals 180 minus ACB. Okay, so all I'm doing is looking at this theorem, and the angle outside the circumscribed angle equals 180 minus the central. So EHF equals 180 minus E, the measure of EGF. Okay, so EHF we know is 30 degrees. So 30 equals 180 degrees minus E, the measure of EGF. Okay, so 180 minus what gives you 30? That's what we have to find. So if I subtract 180 degrees from both sides, I get negative 150 degrees equals negative measure of angle EGF. So if I multiply by -1 on both sides, that gets rid of this negative. So then I have 150 degrees equals EGF. So angle EGF is 150 degrees. Okay. So then we have the measure of angle EJF equal to 1/2 of 180 minus EHF, 30 degrees. So the measure of angle EJF is 1/2. 180 minus 30 is 150, like I had right here. And that's where that's coming from. So if I take half of that, then I get the measure of angle EJF equals 75 degrees. Okay, so EJF is 75, EGF is 150, and the arc EF is 150 degrees. 150 minus 30, or 150 plus 30 is that 180. Okay, so that one was a little more complicated, but it all comes together when you use all the theorems in unison. Okay, so now try example 12. Okay, example 4. This is a little bit tricky. It says modeling with mathematics. The northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 150 miles above Earth at point C. Okay, so this flash occurred right here. Okay, there's the flash at C. It says 150 miles above Earth. So as you can see, AD is a radius of 4,000 miles. Okay, Earth, it says, what is the measure of arc BD? So we want to know what this arc measure is right up here. How much of that Earth is that? The portion of Earth from which the flash is visible. Okay, so the Earth's radius is approximately 4,000 miles. So we know AD is 4,000 and AB is 4,000 because they're radiuses, radii. So A up to the edge of the Earth right here is 4,000. So if I continue on, now I know the length of AC. So AC, the length of AC equals 4,000 miles plus the distance above the Earth the flash occurred. So AC is 4,150 miles. Okay, that's the first thing. The length of AC is 4,150. Now notice what we have here. Move this over like so. We have a triangle. And if I use my theorems, BC is a tangent, AB is a radius, B is a point of tangency, and points of tangency occur when the tangent is perpendicular to the radius or 90 degrees. Okay, I know AB is 4,000 miles. It's the radius. I also know that, so this is A, this is B, and this is C. I also know that AC is 4,150 miles. So I know two sides of a right triangle. I can find the third by the Pythagorean theorem. So C squared equals A squared plus B squared. Now be careful here. That's just the theorem name. But in this situation, I now want to rewrite that because the angles are not named that way. So C is the side opposite angle C, but that's not our hypotenuse, B is. So instead of using this, I'm going to say B squared, our hypotenuse squared, equals A squared plus C squared. Hopefully that doesn't confuse you. AC is our hypotenuse opposite the 90. So it's B squared, the side B. So that is 4,150 squared equals, this is A squared plus, this is C, 4,000 squared. So if I get my calculator out and do 4,150 squared, I get a really big number. So that is let me do this so I can see it. That is 17222,500. So what is that? 17,220,550 equals A squared plus 4 times 4 is 16 with 2, 3, 4, 5, 6 zeros. So 4,000 squared is 16 million. So then when I subtract 16 million from both sides, what do I get? 0, 0, 5 minus 0, 2 minus 0, 2 minus 0, 2 minus 0, 7 minus 0. So now I want the square root of 1,222,500 and hit enter, and I get approximately, so A, when I take the square root of both sides, right? A is approximately 1,105.7 miles. Okay, so that's BC. So this is approximately 1105. I'll just put that for now. Okay, so that's starters. So now I know the radius, I know this distance, and I know this distance, and this is also the same. And how do I know that? Well, CB and CD are tangents, so they're perpendicular to the radiuses, and AC is congruent to itself. And I have two radiuses, so now I have a leg and a hypotenuse. So I know triangle ABC is congruent to triangle ADC by the hypotenuse leg theorem, reflexive property, and then the radiuses are always equal. Okay, so these two triangles are congruent, and therefore CD equals BC. So now they're both 1105. That's where I got that. Okay. So now that I know that those triangles are congruent, corresponding parts are congruent, and I need the measure of angle BCA. So what is the measure of angle BCA? I need this angle measure right here. And so I would say, I know opposite now, I know hypotenuse. So that would be opposite over hypotenuse, which is sine. So the sine of C equals opposite over hypotenuse. The sine of C equals 4,000 over 4,150. And therefore C equals the sine inverse of 4,000 divided by 4,150. Now, if I just cross this out and say 400 over 415, and I go second sine 400 divided by 415, but make sure I'm in mode degree, not radian, degrees, and hit enter, then I get C is approximately 74.5 degrees. Okay, so now I know that is this angle right here. So if I double that, that would be the whole angle BCD. So the measure of angle BCD equals the measure of angle BCA plus the measure of angle DCA. And I know those are both 74.5 degrees. So the measure angle BCD equals 74.5 degrees plus 74.5 degrees. They're congruent because corresponding parts of congruent triangles are congruent. And the measure of angle BCD therefore equals 149 degrees. Okay, so now I know the measure of BCD, that's this. That is an exterior angle. So now I know, what am I trying to find? Keep in mind what I'm trying to find. I'm trying to find the arc measure, okay? So I know the measure of arc BD. So I now know arc BD subtracted from 180. So I can say the measure of, let's see, what do I have here? I found the measure angle BCD is 149 degrees. But by theorem, let me switch colors now. The measure, I don't need my calculator anymore. The measure, actually I'd lost my page cut off when I did that, so I'll stay here. All right, so we want the measure of angle BCD, which is an exterior angle with two tangents. So it is a circumscribed angle, and that equals 180 degrees minus the measure angle BAD, which is my central angle. Okay. But the measure of angle BAD, since it's a central angle, equals the measure of arc BD. So I can say now the measure of angle BCD equals 180 degrees minus the measure of arc BD. Okay. And I know BCD is 149 degrees, so 149 degrees, and that was an approximation, so I'm going to use approximations, right? C was approximately, so this should actually be an approximation as well. 149 degrees equals 180 degrees minus the measure of angle BD. Okay, so now I want to solve for the measure of angle BD, so by subtracting 180 degrees from both sides. And that is going to give me an approximation. Measure of BD is approximately 180 minus 49, which is 31 degrees. Okay, because if I subtract this, I'm going to get a negative on both sides, and I just deleted the negative, or multiply both sides by -1. So the measure of arc BD is approximately 31 degrees. So this is approximately 31 degrees. Okay, that was a little tricky, but hopefully this was enough information to get you to understand enough to do exercise 23. Okay, that brings us to the end of exercise or chapter 10.5. These are the exercises, just a small amount. Last homework assignment of the year. Woohoo! All right. So thanks for watching. Have a great day.